Now, what are those natural phenomena that we are going to deal with in this chapter? Number one is lightning. Right? Now, why and how of lightning and how to protect ourselves from lightning. Okay. Number two is earthquake. Now again, why of and how of earthquake and how to protect, safeguard from these two. Now in the previous video tutorial, we learned about charges, right? Electric charges. They are electric charges. And what do you mean by electric charges? These charges experience a kind of force, and those forces are either attraction or repulsion. And what do you mean by repulsion? Repulsion is moving away from each other, right? So let me again brief what we have learned in this video tutorial to go to the reasons before we go to the reasons of lightning. Or else lightning, we can simply say it is an electric discharge. Now, the moment you read this, lightning is an electric discharge, what does it mean? Right? Please recall an experiment where we have taken a battery, right? We have taken a battery. Let me draw the battery like this, and battery will have a positive and negative terminal, right? And there are some chemicals inside where chemical reaction takes place. Okay, and remember that the current is nothing but flow of negative charges, flow of charges, you can say. So what does this negative terminal mean? Let us not go detail into the electricity topic. What does this negative terminal mean? So just for our understanding now, negative terminal is that point where more of electrons deposited, right? And opposite to that is a positive terminal, and that's why it is completely negative. Okay, and in our experiment we had taken a battery of 12 volt, right? So please recall. Let me include a video clip of that demonstration now, right now, here in front of you. And then what we did is that we tried to connect these two with the help of a copper wire without putting any bulb in between. So what happened here? We got a spark, right? And that is what is electric discharge. Here we have got it artificially, and it happens naturally in the sky. Okay, you may ask me, why not if you take a small cell? If you take a small cell here, I am drawing a cell. This is a positive terminal and this is a negative terminal, and if you connect these two terminals, why we don't get a spark here? The voltage of this cell will be around 0.5 volt. The current which is flowing is very less as compared to this. Okay, this is 12 volt, but the current is more here, right? So wherever there is more amount of current flowing through the wires, whether it is the direct current or an alternate current, you find a spark. You will find spark even, you know, in the electric poles. You will find the wires when they get connected, you find a electric discharge, and that is what is nothing but lightning, which happens naturally in the sky, right? From where the charges come, right? This also we have seen in the previous video tutorials. For those who have not seen already the previous video tutorials, please go through those tutorials. Well, we shall even have a brief understanding about from where these charges have come. We know that there are two kinds of charges. They are positive and negative. And this positive charge is due to proton, and negative charge is due to electron. Now, what are these protons and electrons? They are the basic particles in the structure of atom. We all know that the atom contains a nucleus in the center, right? Let me draw on this slide only. So this contains so many number of protons and so many number of neutrons. Let's say it has got 5 protons and 5 neutrons. They are always equal, and then we will have, 5 electrons all around. Then they will be moving, right? They will be moving in different, right, path around this. So these are responsible for the negative charges, right? Negative charge. Electron is for negative and protons for positive charge. That means every matter is made up of. Matter means you take solid, you take liquid or gas, right? Every matter is made up of atom, and therefore, right, therefore an atom contains positive and negative charges in equal number. So since atom is neutral, therefore matter also will be neutral. But when we rub matter or materials each other, then we find there will be, movement of electrons, right? Or charges, you can say. Better to say charges. So when a particular charge moves from one end to another end, when the electron moves from one end to another end, then the matter will not be no more neutral, right? For example, if a glass rod, right? So remember this, glass rod when rubbed with silk, right? Let's say this is a glass rod, and when this glass rod is rubbed with a silk cloth, it is understood that few electrons will move from, few charges will move from a glass rod to silk, right? So the number of negative charges in silk will become suddenly more, and then in silk will be more, right? This is because of rubbing, right? When we rub each other, and that makes a silk negative. So when a silk has become negative, those negative charges have become more because of negative charges have come from here, and so glass rod becomes positive. Thus how by rubbing we can make materials either positive or negatively charged. Understood? And then we have understood that these charges have, properties. And what is the main property of these charges? Okay, they same charge. Okay, if you bring plus and plus or minus and minus, they repel. And if it is unlike charge, they attract. Right? Not only that, when you bring a positive, this is very important now, positively charged, let's say, glass rod towards a neutral object. This has got equal number of protons and neutrons, so it is neutral. The moment this comes closer, then much of the negative charge will come very near to it, because these two will attract. Understood? Because of which here there will be more of negative charge. And who brought this negative charge? It is because of this positively charged end of the glass rod. Right? We have not touched this. Okay, we have just brought this near, and suddenly there is some flow of charges here at the end. Right? With this information, we'll move further now. Now let us come back to our main question: why lightning? And why are these towers and buildings are shown here? Right? Basically, lightning strikes on tall buildings whenever there is a cloud formation or rain along with that, or we can call it as a thunderstorm. And so this lightning strikes. Lightning will be happening during thunderstorm all the time in the sky. Many a time you may not notice, okay, during particularly rainy seasons. Previously it was thought that it was due to the wrath of gods. Gods became so angry and they fought each other, and that is the reason that lightning could take place in the sky. And that was a belief. Right? Now we understood that lightning is nothing but electric discharge. Remember this is very important concept. As I already explained you what is electric discharge, and we have even artificially created an electric discharge, right? So it happens during thunderstorm. Thunderstorm is heavy cloud, wind as well as rain, right? And during this, so much of voltage will flow through air. Air basically, is a bad conductor of electricity. But there is a moisture in the air, and that conducts electricity. Okay, air will be heated, right? And how much of volts of electricity will be produced because of this lightning? Amazing that it is around 100 million volts of electricity, and that is why it is very harmful. Until Benjamin Franklin, Benjamin Franklin, in his experiment, as he demonstrated that lightning is just a natural phenomena. Lightning is an electric discharge. And it is said that he could understand that accidentally when he was flying a kite. During rainy season, there was bit of a breeze as well as a rain, and he had a keychain which is connected there to one end of the string, and he was flying a kite. and during lightning he could get a shock. Okay, and because of that he could make out that this shock may be because of the electricity which flows through the thread. And then he conducted further experiment and proved that lightning is nothing but electrical discharge. Well, now we'll go back to the towers to understand bit in bit more details, right? These are the towers, tall towers, okay? And during rainy season, you will find a clouds all over. And let's take even a tree here. Generally, lightning strikes on tall object such as towers as well as tree, right? And it happens during the thunderstorm. There is a combination of thunder and storm. Now we all know friction causes or rubbing. Friction or rubbing causes objects charged. Okay, object will become charged. I'll write here, charging is done by rubbing or friction. Okay, and during this thunderstorm, friction is because of the air, right? Air will be rising up in all directions generally, but more of towards upward, understood? And there is a continuous friction between the air molecules and water molecules, right? Basically these clouds are actually molecules of water, and due to constant rubbing they develop a charge. We have already studied, right? Rubbing induces a kind of charge, either positive or negative. Okay, now here it is observed that there are positive charges which settle down at one end of the cloud, and opposite kind of charges will be towards another end of the cloud, right? Now when these charges come closer to this building, the opposite charges, when the negative charge come here, opposite charges will be stored here because the negative charges will be move away. It happens even here. So at this point, you remember it is just like two ends of the battery. One is completely positive, another is negative, and heavy voltage. We had just 12 volt for our experiment, but here more of charge is deposited here, and because of it the moment there is a connection. And how that connection is possible? Because the moisture is there in the atmosphere. Moisture is water particle, right? Bit of moisture, right? And due to that there is sudden discharge called lightning here. So to sum up, okay, lightning is electric discharge, right? So generally what happens during a rainy season, right? Let me draw a cloud here. Because of friction or constant rubbing, these clouds get charged and they are accumulated at different places together, right? So let me show negative charges at the end, one side here, and this concentration of charge here influence or induce either a tree, okay, to have an opposite charge on the top, or a building. Suppose let me make a building here. So this is a building, right? So tall building, So this tall building also will develop a positive charges here, because the negative charges will move away here. So because of this, when they are very close to each other, then there will be a direct contact of positive and negative charge, and then there will be a spark. This will be discharging around 100 million volts of electricity. Just compare with 230 volts of electricity at our home, right? So very interesting phenomena. That's lightning. There are benefits of lightning, okay, that we will see in the future classes, how lightning is useful for us. Okay, every natural phenomena is sometimes appear to be a bit harmful, but there are other sides of the benefits side also. Now going ahead with earthquake. What is an earthquake? Earthquake is a sudden shaking of Earth's surface, and it will last for a very short time, right? So two important points. It's a sudden shaking of Earth, and it will last for a very short time. This is what an earthquake is. So an earthquake is sudden shaking. Please remember this, or trembling of the earth, which will last for a short time, right? Often we read on newspaper earthquakes happening here and there on earth. But please remember that earthquakes occur all the time, all over the earth. Only thing is we don't notice them. We notice only the major earthquakes which are less frequent. These are the earthquakes. They can cause immense damage to buildings, bridges, dams and people. Sometimes these earthquakes results into floods, landslides and even tsunamis. To understand how does an earthquake occur, we need to recall what we have learnt in class 6th as well as class 7th, that is about structure of earth. We have already studied this in previous classes, so we shall just again recall all these contents. What you watch here, this particular portion, is a core, and even this also is a core, but we'll call this as an inner core and this one as a outer core. Both together it is called core. So the first one, which is in the white color background, is inner core, and next one is a outer core, right? So this core together is called core, is in the center of the earth. It is solid, okay, and it has got a very high temperature, around 5000 to 6000 degree Celsius or centigrade, right? You may ask that why, in spite of 5000 to 6000 degrees centigrade, the minerals such as iron and nickel which is there are not in a liquid state. They can even melt, but the pressure on this is so much that it is totally compressed, and therefore there is no option for getting melted. So they are in the form of solid, right? So please remember that core is in the center, and this has a very high temperature. Now the next one is mantle. So this portion is mantle. Again, a mantle can be divided into lower mantle and upper mantle, okay, just for our reference. Because if you go for a lower mantle, let us say from here to here, okay, lower mantle is molten. What does it mean? Molten means it is semi-liquid, okay, it's a semi-liquid, means it is not just like a watery thing, it will flow, but it is kind of a solid, right? When there is an volcanic eruption, you find magma which is coming out, and that is out of this particular part, right? When there is a opening somewhere here on the crust, through this opening the magma goes out. That's we call it as a volcano, right? Now as you go to upper mantle, okay, the matter becomes solid, and then solid, and it solidifies more there, right? And that becomes totally rocky. But it is not a single rock. It's not single. It's fragmented. And what do you mean by fragmented? It is broken. It is there in terms of pieces all over. And these pieces are called plates. These plates are named, right? So you can see right on your screen a different plates here. You see here Eurasian plate. Somewhere here again a Eurasian plate, right? That is the plate where we are very near to. You can even see the direction of how they move. So these plates keep sliding in different directions. So once again, upper layer of the earth is made of small fragments, and these are the fragments. They keep moving. The question is now why they move, right? To understand that, we'll go back to the different layers of the earth and see what do you mean by convection current, right? So let us start from first inner core, right? Inner core is of very high temperature. Now please remember here, inner core is of high temperature, right? I write in short here, which is surrounded by outer core. So both together can be called as core, and this consists of more heavy elements, and it is in the form of solid, right? Please recall what we have learned. And this, after this we have a layer called mantle. Now here we need to discuss more now, and this is the layer which is responsible more for movement of those so-called plates, right? This is layer is mantle, and the one which is very thin here on the top, we all use it for agriculture, cultivation, and to move around, to construct house. That is the layer which is called crust, right? So you will find plates on the earth. And what are plates? Plates are pieces of huge solid, right? And we have learned that they move. The question is, why do they move? Well, this is a time to know about convection currents. Now let us go a bit slow here. Imagine that we are preparing a tea, right? And we put water here in the container. You all know how it is to be prepared. And then we use heat, right, at the bottom. And then over a period of time, this water will start getting heated up and starts boiling. Okay, we also add tea powder here. Now at this stage, if you watch the tea powder, you will find tea powder will be moving to the surface, top surface, and those which are on the top, they come down. We observe this because tea powders are visible. Otherwise also, whenever you boil water in a container, same force will be there which is towards upward and downward when you start heating them, right? This is what is called current. Don't get confused with the current, electric current. It's a force. It's a kind of push. Understood? What actually happening, the molecules of water, particles of water which is there at the bottom, they receive heat first and they move further to the top, and rest of the particles will come down. So there is continuous circulation of hot water to the surface and cold water to the bottom when a water is being heated, right? And this is what is called convection current. Now here in the case of earth, this is very hot and this is semi-liquid. The same thing happens here. How this heat is used to move these particles upward and then downward, the same thing happens here. There is a movement of these particles upward and then the surface particles will come down. This happens all around and causes a convection current in the mantle area, okay, inside the earth. And because of this, there is always a push on the surface rocks, and those are called plates. Understood? So these plates are always pushed, and pushed by what? Convection current. And why convection current? Because of the heat which is there at the core. Understood? So there is always movement of this particle. So continuous movement of this particle develops more pressure on these plates and they start to slide, and sometimes they collide. Collision takes place, and because of the collision there is a disturbance, and that disturbance in the plate results to sudden shaking, and that is what is called earthquake.